Okay, so this part of your lab is a study of kinetics, that is the rates of reactions. We're going to see what causes certain reactions to go faster than others. So what we have here to start us off are some roughly equal size samples of magnesium ribbon. We are going to place those into two different solutions with different concentrations of HCl. Now, when we put a metal into an acid, a displacement reaction is going to occur where the metal pairs up with our chloride, in this case, and generates hydrogen gas. So we should expect to see a good amount of fizzing here. Our focus is going to be on which of these clears up first. You'll notice that the one on the left is 1 molar HCl and the one on the right is the 3 molar HCl. So the difference is the concentration of these two solutions. So I'm going to place the magnesium ribbon into these two test tubes at roughly the same time so that we can see which one clears up first. And you can note the vigorousness of the reaction. One of the interesting things about this lab is that this is an exothermic reaction, so you would note that the test tubes are feeling a bit warm as the reaction releases heat to the surroundings. Our goal here is to see which of these reactions is the most vigorous and which one is essentially completing itself first, which one is fastest. We'll swirl these around a little bit to get better contact with our reactants. So we still have a little bit of magnesium left. Hard to see through all the fizzing, but there's still a bit of magnesium left over here on the left side. So this should help us with verifying what we know about reactions and how quickly they proceed. What are some of the things that cause reactions to go faster? And what does this experiment tell us about concentration and its effect on rate? Continuing with our exploration of rates and what affects the rates of reactions, now we're going to take a look at what happens when, instead of changing the concentration, we instead change the amount of surface area we have for our reactants. So over here I have still magnesium, but in two different forms. On the left I have magnesium ribbon. It's been cut a little bit. And on the right we have magnesium powder, which has a much higher surface area. So let's take a look at what happens when we put them into equal concentrations of HCl. So this time the two test tubes have the same concentration of hydrochloric acid. Add roughly the same time, so we can see which one is going faster, which one is more vigorous, which one is going to clear up first. And one thing to know is that I was careful to weigh out the magnesium that I put in there. They're both about 36 milligrams in terms of their sample size. So the amounts that we're using are the same. All we did was change the form that we use to introduce them to each other. Maybe hard to see against the white paper, but there are still chunks of magnesium floating near the surface of our left side here. If I swirl it around a bit, you can kind of get a peek at them. If I do the same with our other test tube, pretty much goes entirely to foam. We got one of our magnesium chunks to sink over on the left side. So you see a bunch of hydrogen gas now evolving. Meanwhile, there's a good amount of hydrogen evolving in this side, on the right-hand side, from what is left of the magnesium particles. Zoom in just a little bit more if we can. At this point, pretty much spent on our right side, while the left side seems to still have quite a ways to go. So we'll stop it here and let you take your observations. 5-minute update on our previous reaction where we were comparing the magnesium ribbon to the magnesium powder. And as you can see, still ways left to go with our left side here. Whereas this is pretty much done. Next leg of our experiment has us comparing hot and cold. So we are creating a hot bath and heating up a little bit of the hydrochloric acid, 1 molar. And we have a cold bath here for another sample of 1 molar HCl. We're gonna let these arrive at very different temperatures, and then we're going to see how that affects the rate at which our magnesium and hydrochloric acid react. Try and work quickly with this one because we've got the hot and cold now out of their hot baths. Again, roughly equal amounts of magnesium, and we're gonna see how fast these go. So again, the cold is on the left over here. This is the cold, and this is the hot. We'll zoom in a bit. So Again, note how vigorous the reactions are in comparison to each other. The greater the difference in temperature, the easier it is to see the difference in their rate of reaction. As we let this sit for too long, those temperatures start to get closer together. So we start to see the rates sort of reach similar rates. So hopefully that's enough for you to take your observations on the comparison of cold temperature reactions versus hot temperature reactions.